In this video, we're going over the practice solutions for graphing linear inequalities in 1 and 2 variables. So for the first one, x is less than 2, we know this is going to be a vertical line, and it's dashed because it's less than, and the shading will be all the solutions on the left side of the line. For number 2, it's a horizontal line going through -5. Y is greater than or equal to -5, and it's all solutions above the line. Number 3 is an absolute value problem, so it could be either an and or an or compound inequality. The line is dashed, and because it's greater than, makes it an or, so it's all solutions to the right and to the left. With number 4, we have another absolute value, but it's dealing with y, so that means we'll have horizontal lines at 4 and -4. It's solid, and it's going to be an and, everything shaded between the lines. Y is less than or equal to 4, greater than or equal to -4. Number 5, we have two variable problem here, which means there's a y and an x. So we have a slope and a y-intercept. It's already in slope-intercept form, so I can just plot the y-intercept and the slope. It's going to be a solid line. Next, I need to decide which side to shade on the boundary. So I choose a test point 0, 0, and I see it's true, so I shade the side that worked. Number 6 is also in slope-intercept form, so I can plot the y-intercept and the slope. It's a dashed line because it's not equal to. I can use 0, 0 as a test point. Zero is greater than or equal to -6. That's true, so I shade the side that works. Number 7. In this problem, we first have to solve for y to put it in slope-intercept form. Don't forget to change the sign, the inequality, whenever we multiply or divide by a negative. So we have our slope and our y-intercept. I can plot the line. It's going to be a solid line. Then I need to choose a test point. I can use the original equation for the test point, and I see that it's false. 0 is not greater than or equal to 12, so I shade the opposite side. So for 10 and 11, we're going to do the same thing. We're first going to put this into y equals mx plus b form, and then we're going to read the slope and y-intercept, plot the line, use a test point, and shade. For number 11, don't forget about clearing the fraction by multiplying by the inverse. In this case, to get rid of -1/2, you can multiply both sides by -2. You have to flip the inequality here because we're multiplying by a negative number. Okay, let's take a look at a word problem. In number 18, a phone company charges 50 cents per minute during the daytime and 10 cents per minute at night. How many daytime minutes and nighttime minutes could you use in 1 week if you wanted to pay less than $20? So I'm going to set up my variables here, and I know that x is the number of day minutes and y night minutes. So my equation 0.50x plus 0.10y is less than 20. I can clear the decimals by multiplying both sides by 10, so all the terms by 10, and I get 5x plus 1y is less than 20. So the best way to solve these kind of problems is finding the intercepts. we could use the y equals mx plus b equation, but I think if we substitute 0 for x and solve for y, that gives us the y-intercept, and substitute 0 in for y and find the x-intercept, generally is the easiest way to approach these. So I'm going to label my graph, figure out what my scaling is, plot my line, which should be a dashed line, use a test point, and shade. The idea with these problems is there's more than one possible solution. There's a boundary here that gives me a shaded region, and anywhere in this shaded region would work for any one of the x or y combinations. Okay. In number 20, a theater wants to take in at least $2,000 for a certain matinee. Children's tickets cost $5 each, and adults' tickets cost $10 each. First, in part A, we want to write an inequality. So I set up my unknowns. I know that 10 times x plus 5y has got to be greater than or equal to 2,000. In part C, we've skipped to part B, so I'm going to get rid of the parentheses here. We don't need that. We know that we have a minimum, or we have a maximum of 300 tickets. So I can write the total number of tickets has to be less than or equal to 300. X plus y is less than or equal to 300. And so for part D, I want to graph both of these. I can use the intercept idea again. And I'm going to graph both of these inequalities on the same graph. And what we're going to do is see where they overlap. Where the overlapping regions are will be our solution. So on one side, for the red equation, for the money equation, we're going to graph everything to the right. And then for the blue line, which is the number of seats, we graph everything to the left. And where the overlapping area is where our solution is.